Good day, this is Teacher Rodney and welcome to the Science Classroom. Today, we're talking about motion. Specifically, we're talking about distance and displacement. Let's start by defining what motion is. Motion is described as a continuous change in position of a body relative to a reference point, as measured by a particular observer in a particular frame of reference. One way of knowing whether an object is moving or not is by comparing it with another object that is not moving or stays in place. This will be our reference point. Objects that we call stationary, such as trees, road signs, and buildings, make good reference points. An object is said to be traveling when it is moving towards or away from a reference. Whether an object is moving or not depends on the reference point you choose. Let's take a look at this example to further understand the concept of motion. Which object do you think is in motion? Is it the bus or the road? Which will serve as a reference point? In this image, we can infer that the bus is in motion with respect to the road. The bus is moving while the road stays still. Therefore, the bus is the object in motion while the road is our reference point. Let's discuss about distance and displacement. Distance and displacement are both used to describe if an object has moved. Let's define distance first. Distance is the total length of path traveled by an object. It is a scalar quantity. What does a scalar mean? A scalar quantity means that it has only magnitude or size. Other examples of scalar quantities are time, mass, and temperature. On the other hand, displacement is the straight line distance between the initial position and the final position. Displacement is a vector quantity. If distance is scalar quantity, displacement is a vector quantity. What does vector mean? A vector is a quantity that has both magnitude and direction. Acceleration, force, and momentum are examples of vector quantities. Let's take a look at this example. Roniel and Riza are looking for their pet dog Sansan. What is the distance and displacement? In this figure, distance is represented by the two yellow solid arrows. They will have to walk 3 meters east and 4 meters north in order to reach their pet dog. They will have to cover 7 meters because we will add 3 meters plus 4 meters, which is equal to 7 meters. How about their displacement? In this figure, in terms of displacement, it is represented by the red broken arrow. The total distance between the initial and final position is 5 meters northeast. Take note that displacement is a vector quantity which has both magnitude and direction. So, our displacement has always a direction. Let's take a look at this other example. Harriet and Nana are bound to go to school. From their initial location, point A, the supermarket, point B, is 250 meters away. From the supermarket, they have to walk 250 meters more to reach their school, point C. Question number 1. Harith and Nana walk from their initial location, point A, at the same pace and reach the supermarket, point B, at the same time. What is the distance that they have covered? In order to find the distance that they have covered, we must find the distance between point A to point B. As seen in this figure, the distance between point A to point B is 250 meters. So, in equation, distance is equal to AB, which is equal to 250 meters. What is their displacement? Displacement is just the same as the distance, but take note that displacement has always a direction. Therefore, our displacement will be 250 meters east. Question number 2. If Harith and Nana continued walking and reached school, point C, at the same time, what is the total distance that they have covered starting from their initial location, point A? In order to solve this problem, we must find the distance between point A to point C. Therefore, we must add the distance between point A to point B and point B to point C. In equation, distance is equal to AC, which is equal to AB plus BC. Substituting the value, 250 meters plus 250 meters is equal to 500 meters. How about their displacement? Again, displacement is just the same as the distance, but remember that displacement has always a direction. So our displacement will be 500 meters east. Question number 3. When they reached school, point C, Nana realized that she forgot her mulina. She hurriedly returned to their initial location, point A, to get it. What is the total distance that she covered from the original starting point, point A, when she returned to the same location, point A, to get her mulina? In order to determine the distance, we must find the distance between point A to point C and point C to point A. Thus, in equation, we will have distance is equal to AC plus CA. The distance between AC and the distance between CA is the same. So, we will add 500 meters plus 500 meters, which is equal to 1,000 meters. Is the total distance that she has covered the same with her displacement? The answer will be no, because she returned to her original position. So, our equation would be AC minus CA. Since AC is equal to 500 meters, while CA is equal to 500 meters also, therefore, the displacement is equal to 0. Since displacement is defined as the shortest distance between initial position to the final position. Alright, let's have a recap. An object is in motion if it changes position relative to a reference point. In other words, motion is just the change in position. Distance and displacement are two different quantities that are usually interchanged. They both seem to mean the same thing, but they are actually very different from each other. Distance and displacement are two different things because distance is just the length of path traveled by an object, while displacement is the distance plus direction. Remember, again, displacement has always a direction. Let's have this table in order for you to understand the difference between distance and displacement. Distance is the length of path traveled by an object, while displacement is the straight line distance between the initial and final position. Distance is a scalar quantity, whereas displacement is a vector quantity. A scalar quantity has only magnitude, while vector quantity has both magnitude and direction. A good example of distance is 13 kilometers, while for displacement, it is 13 kilometers north. To end this presentation, I want to leave you a short quotation. Distance means nothing when someone means everything. That is from the long distance relationship video from Kwentong Jollibee. Distance doesn't matter as long as you love each other. Thank you for listening. I hope you enjoyed and learned from this video. See you next time. Bye!